Here are 32 practice problems on exponential functions. As per usual, I'll link these questions and the answer key in the description, so if you want to work ahead, you can go ahead and do so. But if you need a little bit more help, I will be going through every single question. Or if you need further clarification, feel free to ask me. Anyways, let's get started with question number 1. The function S above models the annual salary in dollars of an employee n years after starting a job, where A is a constant. If the employee's salary increases by 4% each year, what is the value of A? So here it says the employee's salary increases by 4%, so we know it will be an exponential growth problem. Here's the formula for exponential growth, and you'll see that A is going to be equal to 1 plus R. Now you might be asking what the R value is, and that's going to be 4%. So the value of A will be equal to 1 plus 4%. And remember, to convert a percent to a decimal, all you have to do is move the decimal places 2 points to the left. So you go 1, 2, and you get that it would be equal to 1 plus 0.04, which means our answer would be 1.04 or C. Now you could also do this in desmos. All you have to do is do 4%, and then it'll instantly type the of, and then you put 1, and then it'll give you the decimal value if you didn't want to do it by hand. Question number 2. The equation above estimates the global data traffic, D, in terabytes for the year that is T years after 2010. What is the best interpretation of the number 5640 in this context? So in exponential functions, this very first number here will always be the initial value, whatever number we're starting with. Then, the second number is going to be the rate of growth or the rate of decay, depending on if it's exponential growth or exponential decay. And then lastly, the t will of course be the amount of time. So here, our 5640 is the first number, which means it's the initial value. So now let's look at our answer choices. A. The estimated amount of increase of data traffic. It's not the amount of increase, so that would be it. B. The estimated percent increase in the data traffic. It's not the percent increase. C. The estimated data traffic in terabytes for the year that is T years after 2010. It's not going to be the year that is T years after. It's going to be the amount that was in the initial year. D. The estimated data traffic in terabytes in 2010. So here 2010 would be the initial year, so D would be our answer. Question number 3. A scientist initially measures 12,000 bacteria in a growth medium. 4 hours later, the scientist measures 24,000 bacteria. Assuming exponential growth, the formula of that gives the number of bacteria in the growth medium, where R and C are constants, and P is the number of bacteria T hours after the initial measurement. What is the value of R? So here, they tell us that it's an exponential growth problem, and they're also so kind to even give you the formula, which is gonna be this right here. Now once again, the very first number will be the initial value. And in the information they give to us, they say the scientist initially measures 12,000 bacteria. So 12,000 will be the initial value. Then we're trying to solve for R, so we'll just keep it as R. And then T will be the amount of time. So here they say 4 hours later. So that means the time will be 4. Then finally, to find the value of P, they say that P is the number of bacteria T hours after initial measurement. And then right here it says the scientist measures 24,000 bacteria 4 hours after the initial measurement. So P will be equal to 24,000. And now all we have to do is solve for R, and I'm gonna go ahead and put this in desmos. Instead of an equal sign, I'm gonna put a tilde, and we get that the value of R is equal to 0.25, which is equal to 1/4. So our answer would be B. Question number 4. Emmanuel purchased a certain rare coin on January 1st. The function of that, where 0 is less than or equal to x is less than or equal to 10, gives the predicted value in dollars of the rare coin x years after Emmanuel purchased it. What is the best interpretation of the statement f of 8 is approximately equal to 82 in this context? So we're given that f of 8 is equal to 82. And you should note that f of 8 is just replacing f of x. Now it's also given to us that f of x gives the predicted value in dollars of the rare coin X years after Emmanuel purchased it. We know here that X would be 8, so the amount of time that would pass would be 8 years. Then, as for the predicted value, we know that it's going to be 82. So that means that 8 years after he purchased it, the predicted value would be $82. Alright, so now that we've come up with our own interpretation, let's see what answer choice would match that. A. When the rare coin's predicted value is approximately $82, so predicted value is $82, this first part would check off. It is 8% greater. Never do we ever mention anything about percents, so you don't even need to read the rest of that. B. When the rare coin's predicted value is approximately $82, we did say the predicted value is $82, so that's right. It is 8 times the predicted value. We did not say anything about it being 8 times, so don't need to read the rest of that. C. From the day Emmanuel purchased the rare coin to 8 years after Emmanuel purchased the coin, so 8 years, that is what we wrote. Its predicted value increased by a total of approximately $82. We did not say it increased, so that's not going to be it. And finally D, it's the last one, so obviously it's our answer, but let's go ahead and read it. 8 years after Emmanuel purchased the rare coin, 8 years, that matches up. Its predicted value is approximately $82. That also matches up, so yep, it would make sense. Question number 5. From 2005 through 2014, the number of music CDs sold in the United States declined each year by approximately 15% of the number sold the preceding year. In 2005, approximately 600 million CDs were sold in the United States. Of the following, which best models see the number of millions of CDs sold in the United States 2 years after 2005? So here it says the number of CDs declined, so we know that we'll have a exponential decay problem. Here's the formula for exponential decay, and you notice that the first part, as well as the t, stays the exact same in every single answer choice. So that means all we really have to do is find out this middle part, 1 minus r. Now you might be asking, what's the r value? Well, that's just the percent. Here it's going to be 15%. So that means we would do 1 minus 15%. And remember, to convert a percent, you would just move the decimal place 2 points to the left. So 1, 2. You get that would be 1 minus 0.15, which means our answer would be 0.85. Okay, I ran out of space over there, but 0.85. And the only answer choice with 0.85 is B. So that means our answer is B. Now you should also know that here, since it's exponential decay, the number inside the parentheses should obviously be smaller than 1, so it wouldn't be C or D. And then you should also know that it's always going to be 1 minus. It will never actually be the percent itself. So through that logic, you wouldn't even need to actually solve for it. You could just do process of elimination. Question number 6. I usually like to include the header, but I ran out of space here, so sorry for that. The graph gives the estimated number of catalogs, Y, in thousands, a company sent to its customers at the end of each year, where X represents the number of years since the end of 1992, where 0 is less than or equal to X is less than or equal to 10. Which statement is the best interpretation of the y-intercept in this context? So let's go ahead and find our y-intercept, and it's going to be right here. The point is going to be at 0, 9. We know that the y value is the number of catalogs in thousands a company sent to its customers at the end of each year. So here at our y-intercept, that means that they sent 9,000 catalogs. And then the x value is the number of years since the end of 1992. Here our x value is 0, so that means it's just been 0 years since the end of 1992, or it's literally just the end of 1992. Alright, now that we have all of our information, let's piece together our own interpretation. At the end of 1992, the company sent out 9,000 catalogs. Now let's go ahead and look at our answer choices and see what best matches our interpretation. A. The estimated total number of catalogs the company sent to its customers during the first 10 years. We didn't say it was the first 10 years, so A is in our answer. B. The estimated total number of catalogs the company sent to its customers from the end of 1992 to the end of 2002. We didn't say anything about the end of 2002, so B isn't our answer. C. The estimated number of catalogs the company sent to its customers at the end of 1992 was 9. We said it was 9,000, not 9, so C isn't our answer, which means that D is obviously our answer, but let's just check to be sure. The estimated number of catalogs the company sent to its customers at the end of 1992 was 9,000. Okay, it won't let me underline it, but both parts do check out, which means our answer would be right. Question number 7. The function of that gives the number of bacteria in a population t minutes after initial observation. How much time in minutes does it take for the number of bacteria in the population to double? Alright, so I went ahead and rewrote the function. We know that the first number is the initial value, so our initial value is 60,000. Then the second number is the rate of growth, and here the rate of growth is 2. So they ask us how long it would take for the number of bacteria in the population to double. Now we know that the number of bacteria is 60,000, and to double it, you would multiply it by 2, which is quite literally what we have here, 60,000 times 2. However, there's one small problem. You have this fraction as an exponent right here. It's 60,000 times 2 raised to the power of some fraction. That means what we're trying to do is get rid of this fraction. So to do that, we can just set it equal to 1, because if we did 60,000 times 2 to the power of 1, that would be the same as 60,000 times 2. So now I think it's kinda obvious, but t would have to be equal to 410 for the fraction to be equal to 1, which means our answer would be 410. Now I know my explanation was probably pretty bad and confusing, so let me show you what this would look like in Desmos. Alright, so here's our function, and once again our goal is to get to 60,000 times 2 so we can double it. Now right now, if t is equal to just some random fraction, then this value would never equal 120,000 or 60,000 double. Now let me change the slider to 400, and once again, it won't reach 120,000 unless you set the fraction equal to 1. So that means that t would have to be equal to 410, and then it would be equal to 120,000. Question number 8. A certain college had 3,000 students enrolled in 2015. The college predicts that after 2015, the number of students enrolled in each year will be 2% less than the number of students enrolled in the year before. Which of the following functions models the relationship between the number of students enrolled, f of x, and the number of years after 2015, x? So here it says the number of students will be 2% less. So we know it will be an exponential decay problem, and the formula for exponential decay is this. Now unfortunately, the answer choices don't all look the same, so I guess we actually do have to write the equation ourselves. They ask us to use f of x, so we would do f of x is equal to, this first number will always be the initial value, which is 3,000 students, and then 1 minus the r value is going to be the percent, which is 2%, so 1 minus 2%, and then instead of t, they want us to use x to the power of x. Now, to convert a percent to a decimal, all you have to do is move the decimal place 2 points to the left. So that would be 1 minus 0.02, which is equal to 0.98. So our equation would be f of x is equal to 30,000 times 0.98 to the power of x. And the answer choice that matches this is D. Now you could have also solved this without actually solving for this equation. We know here it's an exponential decay problem because they say it's less. That means that the number inside the parentheses has to be less than 1 because we're doing 1 minus. That means our answer couldn't be A or B. Then we know that the number inside the parentheses will never be the percent. It will never be 2% because once again you have to do 1 minus first. That means our answer couldn't be C either, leaving us with only D. Question number 9. According to Moore's law, the number of transistors included on microprocessors doubles every 2 years. In 1985, a microprocessor was introduced that has 275,000 transistors. Based on this information, in which of the following years does Moore's law estimate the number of transistors to reach 1.1 million? So here it says the number of transistors doubles So we know it will be an exponential growth problem. And here's the formula for exponential growth. Now let's go ahead and fill this out. We know that the first number will be the initial value, and here the initial value is 275,000. Then we know that the second number will be the rate of growth. Now normally we would do 1 plus r, which would be 1 plus the percent. But here they tell us that the number of transistors doubles, which means that the number inside the parentheses would just be a 2. And then it's going to be raised to the power of t, which is what we're trying to solve for. Now, there's going to be one small change we need to make. It says that it doubles every 2 years. So what we're going to have to do is put this t over 2 like this. Now I just want to show you quickly how this would look like in desmos. Alright, so I went ahead and put in desmos, and you'll see that after 1 year, it will increase to that amount, and then after 2 years, it will double. Now if you didn't put it as t over 2, and instead just kept it as t by itself, after 2 years, then it would end up being 1.1 million, which is actually quadruple and not double. That's why we have to put it over 2 when it says every 2 years. Alright, and now they're asking us how long it takes to reach 1.1 million, so we're gonna set this equal to 1.1 million. And now all we have to do is solve for t, and we can just put this back into desmos. I'm gonna put this over 2 again, and then instead of an equal sign, you want to put a tilde, and delete this t equals 2 because we're actually trying to find what the t would be equal to, and we get that t would be equal to 4. Now you notice that 4 isn't any of our answer choices, so what this means is that it will take 4 years. We know that the initial year was 1985, so 4 years after 1985 would be 1989. Question number 10. The function f is defined by that. What is the value of f of 0? Now you should note that 0 in our function would take the place of x, so it would look like this. Now there's like 3 different ways you could solve this. The first way is that you should know anything raised to the power of 0 is just equal to 1. So if you did 270 times 1, you would get the answer would be b. Now you could also interpret this as a word problem. Here, 0 would be the time, which would be at 0 years, so they're asking us what the value would be in 0 years. The very first number is the initial value, or the value at 0 years. So that's how you could get 270 again. I just realized I circled b instead of 270, anyways. Or you could also put this in desmos, 270 times 0.1 to the power of 0, and you would get 270 again. Question number 11. The function of that models the value in dollars of a certain bank account by the end of each year from 1957 through 1972, where x is the number of years after 1957. Which of the following is the best interpretation of f of 5 is approximately equal to 243 in this context? Alright, so this is just like some question we had earlier, and we know that f of 5 is equal to 243. Now you should remember that f of 5 is taking the place of f of x, and we know that x is the number of years after 1957, so here it would be 5 years after 1957 or 1962. Then we know that f of x is equal to the value in dollars of a certain bank account by the end of each year. So here it would be $243 in the bank account. F of 5 is approximately equal to 243 would mean that there's $243 in the bank account in 1962. Now let's look at our answer choices and see what would match that interpretation. A. The value of the bank account is estimated to be approximately $5 greater. We did not say anything about $5 greater, so A is in our answer. B. The value of the bank account is estimated to be approximately $243 in 1962. That matches up, so B will be our answer. Question number 12. The function n defined above can be used to model the number of species of brachiopods at various ocean depths, d, where d is in hundreds of meters. Which of the following does the model predict? So here we know that d is in hundreds of meters, so we can instantly get rid of a and b where they only say 1 meter. Now let's look at c. For every increase in depth by 100 meters, the number of brachiopod species decreases by 115. Well, we know 115 is the first number, which means that's the initial amount. It's not the amount that it's decreasing by. So C won't be our answer either, which means D has to be our answer, but let's go ahead and read it. For every increase in depth by 100 meters, the number of brachiopod species decreases by 10%. Now you should remember that to get the number inside the parentheses, you'll do 1 minus r, where r is the percent. So here they say it's 10%, and let's plug that in, 1 minus 10%. Then to convert a percent to a decimal, you would move the decimal place 2 times to the left, so you would do 1 minus 0.1, which is equal to 0.9, and that does match up, so D would make sense. Question number 13. A company opens an account with an initial balance of $36,100. The account earns interest and no additional deposits or withdrawals are made. The account balance is given by an exponential function A, where A of t is the account balance in dollars t years after the account is opened. The account balance after 13 years is $68,071.93. Which equation could define A? So here it says the account earns interest, which means it's gonna be an exponential growth. Here's the equation for exponential growth, and we know that the first number is going to be the initial amount. And here it says the initial balance is $36,100. Now if we look at our answer choices, that means we can instantly get rid of B and C since it doesn't start with 36,100. Then, you notice that the number inside the parentheses, you're gonna have to do 1 plus. This means that no matter what, it always has to be greater than 1. Now if you look at D, the number is less than 1, which means that's gonna be wrong. So A has to be your answer. Now if you really wanted to, you could solve it by hand, so let me go ahead and show you how to do that. First, I'm gonna plug in our values. We know the initial balance is 36,100. We don't know the value of 1 plus r, so we can just keep it as that for now. And then we know the value of t is 13 years. Then we know that this entire equation is equal to $60,071.93. And now we can solve for 1 plus r. Instead of an equal sign, I'm gonna put a tilde. And we get that r is equal to 0.05. But remember, to get the number inside the parentheses, you're gonna have to add 1 to that. And you get that the number inside the parentheses would be 1.05, and that does match A. Question number 14. The table above gives the values of the function f for some values of x. Which of the following equations could define f? So what I'm gonna do here is just plug each of those equations into desmos and see if they share the same points as the ones in the table. So first up, let me type the points in the table. Now to do that, you can click the plus sign right here, and then table, and now I'm gonna just type in all of the points. Alright, so now we have all our points, let's start typing in our answer choices. Here's A, it definitely does not share those points, so A was not our answer. Here's B, once again it definitely doesn't share those points, so B isn't gonna be our answer either. Here's C, once again it doesn't share those points, so C isn't our answer either. Here's D, and you notice it does share all of those points, so that means D is our answer. Question number 15. The exponential function g is defined by that, where a is a positive constant. If g of 3 is equal to 2375, what is the value of g of 4? So you should remember that this number right here can replace g of x, and then this number right here can replace x. So let's go ahead and rewrite that equation. Now that we have rewritten our equation, let's go ahead and solve for a, and I'm gonna just do this by putting it in desmos. Now instead of an equal sign, you want to put a tilde, and then we get that the value of a is equal to 5. And now we can just go ahead and plug in 4 for x instead. So 19 times 5 to the power of 4, or 19 times a to the power of 4, both would get you the same answer of 11,875. Question number 16. The equation that gives the estimated number of employees at a restaurant, where t is the number of years since the restaurant opened. Which of the following is the best interpretation of the number 5 in this context? So here, 5 is the first number, and you should remember that the first number is the initial value. So that means that 5 is the initial amount of employees the restaurant had. Now let's go ahead and look at our answer choices. A. The estimated number of employees when the restaurant opened. Yep, that's right, so that means our answer is A. Question number 17. Bacteria are growing in a liquid growth medium. There were 300,000 cells per milliliter during an initial observation. The number of cells per milliliter doubles every 3 hours. How many cells per milliliter will there be 15 hours after the initial observation? So here it says that the number of cells doubles, which means we're experiencing exponential growth. And here's the formula for exponential growth. Now let's go ahead and start plugging in our numbers. We know that the first number is the initial amount, and here it says that there were 300,000 cells during an initial observation. So 300,000 is our initial amount. Then our second number will be the rate of growth. Now normally we add R, which is a percent increase. However, in this question, it just says that it's doubling, so we'll put a 2 inside the parentheses. And lastly, our time, which is t. However, there is one more part we need to add, and since it says every 3 hours, we need to put this t over 3. Now just like I did in the previous question we had like this, let me show you what it looks like in desmos. So here it is in desmos, and if t is 1, which means after 1 hour, it will be that amount. And then if we change t to 3, after 3 hours, it will be double, which matches up with what the question says. Now if we didn't put t over 3, then after 3 hours, it would be 2.4 million, which is actually 8 times the amount. So you definitely want to make sure to put it over 3 when it says it doubles every 3 hours. Now they're asking us how many cells there will be after 15 hours, so that means we have to set t equal to 15, and we get that the answer would be 9.6 million, which is D. Question number 18. There were no jackrabbits in Australia before 1788, when 24 jackrabbits were introduced. By 1920, the population of jackrabbits had reached 10 billion. If the population had grown exponentially, this would correspond to a 16.2% increase, on average, in the population each year. Which of the following functions best models the population P of t of jackrabbits t years after 1788? So here it literally tells us that the population has grown exponentially, which is exponential growth, and here's the formula for exponential growth. Now the first number is the initial amount, and it tells us that the initial amount is 24 jackrabbits. So that means our very first number has to be 24, which means we can eliminate A and D since the first number isn't 24. Now if we look at B, the number inside the parentheses is 2. And if you remember the last question we had, you only put a 2 in the parentheses if it's doubling. Now here it says there's a 16.2% increase, which is not doubling, so B won't be our answer either, which means our answer has to be C. Now this is also really easy to solve for the number in the parentheses. You would just do 1 plus R, which is the percent increase, so you do 1 plus 16.2%. And then to convert the percent to a decimal, you would move the decimal place 2 points to the left. So you would do 1 plus 0.162 to get 1.162, which does match our answer. Question number 19. The function f is defined by that. What is the y-intercept of the graph of y equals f of x in the xy plane? I mean, just put this in desmos. Alright, and we see here that our y-intercept is 0.14, so that means our answer is A. Question number 20. The given function f models the number of advertisements a company sends to its clients each year, where x represents the number of years since 1997, and 0 is less than or equal to x, which is less than or equal to 5. If y equals f of x is graphed in the xy plane, which of the following is the best interpretation of the y-intercept of the graph in this context? Alright, so a little trick to exponential equations is that the y-intercept will always be this very first number. Now, in the context of word problems, that very first number is also the initial value. So that means the company sent 9,000 advertisements in its initial year, which is 1997. Now just to prove it, if you go ahead and look here, well it's 9,000, so I guess I have to zoom out a lot. And you see that the y-intercept is right here at 9,000. Okay, well I keep zooming in, but you can't tell it, but it's at 9,000. Anyways, let's go ahead and look at our answer choices. A, the minimum. Alright, no one's yapping about minimum, so it's not going to be A, or B at that. C, the estimated number of advertisements the company sent to its clients in 1997 was 1,708. I have no idea where they got that number from, but that's not 9,000, so it's not C, which means it has to be D, but let's just read it. The estimated number of advertisements the company sent to its clients in 1997 was 9,000. Yep, that matches up. Question number 21. Function f is defined by that equation where a and b are constants. In the xy plane, the graph of y equals f of x minus 12 has a y-intercept at that point. The product of a and b is 320 over 7. What is the value of a? So first up, let's go ahead and plug f of x, this equation right here, into this equation over here. Alright, so I went ahead and plugged f of x into that equation, and we know that this equation has a y-intercept at 0, negative 75 over 7. This means that we can plug in 0 for x, and then negative 75 over 7 for y. Alright, so I went ahead and plugged in 0 and negative 75 over 7, and we get this equation right here. Now you should also note that anything raised to the power of 0 is equal to 1. So we can go ahead and write negative a to the power 0 as just negative 1. Now we can put this in desmos to solve for the value of b. Instead of an equal sign, you want to put a tilde. And we get that the value of b is equal to that number right there. And I'm going to go ahead and type this in. Now it also says that the product of a and b is 320 over 7. So basically, a times b is equal to 320 over 7. Now instead of an equal sign, I'm going to put a tilde, 320 over 7, and we get that a is equal to 20. Question number 22. The function f is defined by that equation where a and b are constants. In the xy plane, the graph of y equals f of x has an x-intercept at 2, 0 and a y-intercept at 0, negative 323. What is the value of b? Now here, they tell us it has a y-intercept at 0, negative 323. So that means we can plug in 0 for x, and then negative 323 for f of x. Now you should also know that anything to the power of 0 is 1, so we can rewrite a to the power of 0 as just 1. And to get b by itself, let's just subtract 1 from both sides to get that b is equal to negative 324. Question number 23. Now you notice that this one looks a little off because if you look at the answer key, the answer choices are actually messed up, so I went ahead and rewrote them. A model estimates that at the end of each year from 2015 to 2020, the number of squirrels in a population was 150% more than the number of squirrels in the population at the end of the previous year. The model estimates that at the end of 2016, there were 180 squirrels in the population. Which of the following equation represents this model, where n is the estimated number of squirrels in the population t years after the end of 2015 and t is less than or equal to 5. So here it says the number of squirrels was 150% more, which means we have exponential growth. Here's the formula for exponential growth. Now we know the first number is going to be the initial amount, and you would think that 180 would be the initial amount. However, it actually isn't. 180 is the amount in 2016. However, the initial amount would be the number of squirrels in 2015. So that means that we can instantly get rid of C and D that have 180 as the first number. Now we also know that for the number inside the parentheses, we have to add 1 to the percent increase. So that means that we know A is not going to be the answer because the number inside the parentheses is just the percent increase, which means that B is going to be our answer. Now if you really wanted to, you could solve for the number inside the parentheses. That would be 1 plus 150%. And then to convert a percent to a decimal, you would move the decimal point 2 places to the left. So that would be 1 plus 1.5, which would be 2.5, which does match what we have in our answer choice. If you're feeling extra hardworking, you could also solve for the first number, the initial value. So we know that the number inside the parentheses, the rate of growth is 2.5, we just solved for that. We're also trying to find the initial value, so we'll just call that x for now. As for our last two numbers, we're gonna put 180 squirrels right here, and then we know that was the amount in 2016, which was 1 year after 2015. So we're gonna put a 1 for t. And now we can just solve for x by dividing the entire thing by 2.5. 180 divided by 2.5 is 72, which does match what we have in our answer. Now you don't really need to do any math in this question at all, as long as you recognize 180 isn't going to be the first number, and 150% isn't going to be the number in the parentheses. Question number 24. The function f gives the value in dollars of a certain piece of equipment after X months of use. If the value of the equipment decreases each year by p% of its value the preceding year, what is the value of p? So here it says that the value is decreasing, which means it's an exponential decay problem. Here's the formula for exponential decay. And you notice that the number inside the parentheses, the rate of decay, is 1 minus r, where r is going to be the percent decrease. So here r would be equal to p%. Now we can go ahead and solve for p. We know that 0.64 is equal to 1 minus r, or 1 minus p%. Now let me put this in desmos. Instead of an equal sign, you want to put a tilde. And then you want to put a 1 after the percent. And you get that p is equal to 36, which means our answer is C. Question number 25. The given function f models the number of coupons a company sent to their customers at the end of each year, where t represents the number of years since the end of 1998, and 0 is less than or equal to t, which is less than or equal to 5. If y is equal to f of t is graphed in the ty plane, which of the following is the best interpretation of the y-intercept of the graph in this context? Alright, so we just had a question like this, and a trick to these exponential equations is that this first number is the y-intercept. Now, in the context of word problems, that first number is also the initial value. So that means that 8,000 is the number of coupons the company sent in the first year, which is 1998. Let's go ahead and read our answer choices. A, the minimum. Nowhere did it mention anything about a minimum, so it's not going to be A or B. C, the estimated number of coupons the company sent to their customers at the end of 1998 was 1,428. I have no idea where they got 1,428 from, but that's not it. So that means our answer will obviously be D, but let's go ahead and read it. The estimated number of coupons the company sent to their customers at the end of 1998 was 8,000. Yep, that perfectly matches up. So that means D is our answer. Question number 26. The function p models the population in thousands of a certain city 2 years after 2005. According to the model, the population is predicted to increase by n% every 18 months. What is the value of n? Alright, we just had a question like this 2 problems ago, except that question we had exponential decay, but this problem it says that it's increasing by n%, which means it's exponential growth. Here's the exponential growth formula, and you notice that the number inside the parentheses, 1 plus r, that's going to be our rate of growth, and here r is going to be equal to n%. So we know that 1.04 is equal to 1 plus r, which is also equal to just 1 plus n%. Now we can go ahead and put this in desmos to solve it. Instead of an equal sign, you want to put a tilde, and then after the percent, you want to make sure to put a 1. And we get that n is equal to 4, which means our answer is C. Question number 27. For the function f of 0 is equal to 86, and for each increase in x by 1, the value of f of x decreases by 80%. What is the value of f of 2? So here it says that f of x is decreasing, which means this is an exponential decay problem. Here's the formula for exponential decay, and let's go ahead and fill this out. We know this function is f of x, so we'll do f of x is equal to, we know that f of 0 is equal to 86, so this means that our initial value is 86. Then we're going to do 1 minus, our r value is going to be 80%, and then this will be to the power of t, but in this case, since it's f of x, it will be to the power of x. Now we can just put this straight into desmos. Make sure to put a 1 after you put the 80%. And now we have our function. They ask us for the value of f of 2, so all we gotta do is type in f of 2, and we get that f of 2 is equal to 3.44. Question number 28. The equation above models the number of members m of a gym t years after the gym opens. Of the following, which equation models the number of members of the gym q quarter years after the gym opens? So here it says q quarter years, and you know that a quarter of something would be equal to 1/4. So I mean, if you look at the answer choices, you have q over 4 here, and you know, like that's 1/4. So our answer would be A, if you know what I'm saying. Question number 29. The function f is defined by the given equation. If g of x is equal to f of x plus 2, which of the following equations defines the function g? So what we can do here is just plug f of x, this equation right here, and g of x, that equation right here, into Desmos, and then we can plug in all of our answer choices, and if the graphs match, then that's our answer. So there's f of x, now I'm gonna plug in g of x, and here's g of x. Now you can click the colored circle to the left to turn off the graph, so I'm gonna turn off f of x because we don't need to see that. Now let's start plugging in our answer choices. Here's answer choice A, and the graphs do not match, so A won't be our answer. Here's answer choice B, and the graphs do match, so that means that B will be our answer. Question number 30. The given function P models the population of Lowell T years after a census. Which of the following functions best models the population of Lowell M months after the census? So here we know that T represents 1 year. So we know that T, which is 1 year, is also equal to 12 months. So that would be M, which is the amount of months, over 12. So if we go ahead and look at our answer choices, our answer could be either C or D because they replace T with M over 12. Now here, our answer is going to be D because there's no reason that the rate of growth, the 1.06, should be over 12. You shouldn't be messing with that. Question number 31. The population of a town is currently 50,000, and the population is estimated to increase each year by 3% from the previous year. Which of the following equations can be used to estimate the number of years, t, it will take for the population of the town to reach 60,000? So here it says the population is increasing, which means this is an exponential growth problem. Here's the formula for exponential growth. We know that the first number will be the initial value, and it says the initial value is 50,000. So we can go ahead and get rid of A and B. Then we know that for the number inside the parentheses, we'll always be adding 1 to it, which means it has to be a number greater than 1. C, the number is less than 1, which means it can't be C, so our only answer left is D. Now if you really wanted to, you could solve for the number inside the parentheses. R would be the percent increase, which is 3%, so we would do 1 plus 3%. To convert a percent to a decimal, you move the decimal places 2 times to the left, so it would be 1 plus 0.03, which would be equal to 1.03, which does match what we have in our answer. Question number 32. For the function q, the value of q of x decreases by 45% for every increase in the value of x by 1. If q of 0 is equal to 14, which equation defines q? So here it says the value of q is decreasing, so this is an exponential decay problem. Here's the formula for exponential decay. We know our first number is going to be the initial value, and it says q of 0 is equal to 14. So 14 will be our initial value. That means we can go ahead and get rid of A and B. Now, we know in exponential decay, you're always going to be subtracting by 1, which means the number inside the parentheses should always be less than 1. That means we can get rid of D since the number inside the parentheses is greater than 1. That means our answer will be C. Now if you wanted to, you could solve for the number in the parentheses. So what you would do would be 1 minus the R, and here R will be the 45%, which is the percent decrease. So 1 minus 45%. To convert percent to a decimal, you'll move the decimal place 2 times to the left. So we do 1 minus 0.45, which would be equal to 0.55, which does match what we have in our answer. Alright, that was 32 practice problems on exponential functions. And I think you can tell, but these questions are really repetitive. I mean, 50% of it is writing equations, 40% of it is interpreting these problems, so reading, and then 10% of it is when you actually have to solve for something. But I mean, being repetitive isn't bad because these questions are really easy. You only need to memorize 2 formulas, the exponential growth formula and the exponential decay formula. Some extra tips that will help speed up these questions are that whenever it's an exponential decay, the number inside the parentheses will always be less than 1, and whenever it's exponential growth, the number inside the parentheses will always be greater than 1. It's also useful to note that the y-intercept will always be this first number, and whenever it says every 3 hours, make sure to put that into a fraction for the time, so make sure to put it over 3. Alright, that's gonna be it. Good luck studying, and I'll see you.